Okay, in the last video we talked about how we have this alternative formula for the area of a triangle, which is 1/2 times the product of two sides times the sine of their included angle. And what I want to do here is derive this, show where it comes from, and then do a couple more examples before wrapping up section 10.1. So let's take a triangle, non-right triangle, and represent it kind of the same way that we've been doing. I'm going to say that this is angle alpha right here. In fact, I didn't need to put that, which would make this A, let's call this B, and this C right here. I'm not going to need to label beta and gamma for this because we're not going to need it, but I will use the altitude of this triangle, and I'm going to call that H, okay? So one thing we're going to need for this is a representation of H in terms of alpha and B. So I know that if I took the sine of alpha, that's equal to, using the fact that this is the right triangle right here, opposite over hypotenuse, which is going to look like H over B. Solving for H is going to give me B sine of alpha equals H. Okay, so that's important because if we now think about what the area formula for a triangle is that you know from geometry, the area of a triangle is 1/2 times the base of the triangle times the height. Okay, well, in our case here, the base of this triangle is given by the side C, so that would be C. The height of this triangle is given by H, but I came up with an alternative representation for H right here, so I can call that B sine of alpha. And if you notice, if I just rearrange the B and the C here, that gives me the first of these three area formulas for this triangle. So that proves this first one. The other two can be proven just by rotating this triangle and using a different side as the base, either B or A, and then using angle beta or angle gamma. So we don't need to prove those individually. But let's use an example, or let's work through an example where we need to use this. Okay, so up here, we want to find the area of a triangle, knowing A, B, and gamma. We have 12 inches, 8 inches, and gamma is a 47-degree angle. So I'm just going to use the formula directly here. My area, A, will equal 1/2. Now remember, there's three formulas, but the one that we want to use is AB sine of gamma. Okay, which would be 1/2. A is 12. B is 8. Gamma is 47 degrees, sine of 47 degrees. Okay, that can go straight into a calculator. And again, as I said in one of the previous videos in chapter 10, we're working primarily with degrees in most of these sections. Make sure your calculator's in degree mode when you're working through these problems. This comes out to approximately 35.1. Now you'll notice there's units given here, and you do need to remember that this is an area, so we measure area in square units. These would be square inches. That would be my answer. All right. One more problem that I want to work through. This one comes out of your book, but it's not worked out in your book. It's one of those try it problems that they sprinkle in there. We don't need the area formula for this one, but instead what this is an application of being able to solve a triangle in, like, you know, in an actual word problem. So what we have here is a blimp. In fact, I'm just going to read this. So the diagram here shows the height, or represents the height of a blimp over a football stadium. The height of the blimp what we want to find is the height of this blimp if the angle of elevation at the southern end zone is 70 degrees, which is shown here. The angle of elevation from the northern end zone is 62 degrees, shown here. And the distance between the viewing points of the two end zones is 145 yards. So that's shown here. Again, what we're trying to find is the height. The height is the same thing as the altitude of this triangle. Now, we don't have enough information quite yet to find this in one step. However, if I was able to find this side right here, then I could use some right triangle trigonometry to then find h. So I'm going to label that side B. Notice that the vertices in this triangle are labeled capital A, B, and C instead of alpha, beta, and gamma. That's actually very common in other textbooks, to not use Greek the way that we are frequently doing, but to use capital letters for angles where lowercase letters are used for sides. So we're gonna use that convention for this problem. So now what I want to do is try and find side B, but using my law of sines. So one thing that I can do before trying to find B is determine this angle right here. That would be angle C. And I can do that because I have two of the three angles already in this triangle. So angle C, or the measure of angle C, is equal to 180 minus 70 minus 62. Excuse me. So let's see, what would that equal? That's going to be, is that 48? Yeah, 48. So we know that angle C is 48 degrees. And then what I'm going to do is even label that in the triangle if I want. Now what I want to do is set up my law of sines. So now I have angle C, but I also know side C. Even though it's not labeled C, it's opposite angle C, and it's 145. So I'm going to use those in my law of sines. Sine of angle C, which is 48 degrees, over side C, which is 145 yards. Now think about what it is we are trying to find. We don't care what A is. I don't need to solve the entire triangle. I just need some of that information. So I'll use angle B and side B next. Angle B, I know, it's 62 degrees. And I'm going to put that over the unknown side, B. We cross multiply to solve this. B is going to equal 145 sine of 62 degrees over sine of 48 degrees. And again, that goes into a calculator. This comes out to approximately 172.28. And we are not done, because that's not the height of the blimp. It's just a piece of information that we need to then find the height of that blimp. So now what I want to do is use the fact that we're looking at a right triangle here and set up another easy trig problem to solve for h. So I have angle 70 here, and h and b are the opposite sides, the opposite side and hypotenuse respectively. So that's setting me up for a sine of 70 degrees. If I did that, sine of 70 degrees is opposite over hypotenuse, so that's equal to h over b, but now we know what b is equal to, 172.28. I can solve for h by multiplying both sides by 172.28. And again, remember, wait until this step to plug things into a calculator. So this is going to come out to approximately 161.89. And then remember that we do have units in this problem. Distances have been measured in yards. So I'm going to say that this is 161.89 yards. Okay? And that's going to wrap up section 10.1 for us.